In this video, I will show how to annotate cells with a custom cell type reference in single-cell RNA sequencing data in Chipster. Firstly, I'm gonna introduce how this custom reference is used to annotate cells. For this, we use a package called SingleR. So, SingleR needs two objects. The first is a zeroed object that has no annotations yet, and the second object is the reference object that has the labels and also expression information. SingleR works so that firstly it calculates the Spearman correlation between the two datasets and their expression. Then it scores each label and picks the top scoring label. And lastly, SingleR performs a fine-tuning step to improve resolution between closely related labels. And this is optional. So how can this be used in Chipster? The tool is called Annotate Cells with Own Reference, and all you need is a pre-processed zeroed object that has at least cluster and UMAP information and the reference object. In this case, the object has to be a summarized experiment object. And finally, the output files of this tool. So firstly, we get this annotated zeroed object with the cell types. We also get this custom reference plots PDF file that has at least a UMAP of cell types and a cluster of cell types. If pruning parameter is enabled, you will also get a score heat map and delta distribution plot showing the accuracy of the labeling, and this can be used for sanity checking. Here is an example of these plots. So firstly, here we have the delta plot. SingleR calculates a delta score for each cell. And this delta score is the difference between a cell's score for its assigned label and the median score across all labels for that cell. So a large delta score means confident labeling, and a small delta means the assignment is a bit uncertain. Low confidence cells are pruned out, and they are shown with the yellow color here. The next plot is a heat map that shows correlation scores for every cell against every reference label. So the cells are columns here, and the labels are row names. The correlation goes from purple to yellow, purple being lower and yellow being high. And for example, we see that these columns here, these cells are labeled with this darker blue color, which stands for naive CD4 positive T cells. And then we have the label naive CD4 positive T cells here. So if the labeling is good, these should correlate well, and so it does because the color is bright yellow. Then here we have a normal UMAP of the assigned cell types per cell. And finally, the last UMAP here shows the cluster cell type. So every cluster gets a specific one cell type based on majority of that cluster cells. So for example, if in cluster 1, 70% of cells are T cells, then cluster 1 and all cells in cluster 1 are gonna be labeled as T cells in this type of cluster cell type plot. And this labeling is based on the majority principle. Next, I'm gonna demonstrate how to use this tool in Chipster. Here I have two objects. The first one is summarized experiment reference object that has the label information. And the second one is a zeroed object that has no annotations, but this is pre-processed so that it has at least the clustering and UMAP information. I have already chosen the tool I want to use and showcase, so I'm gonna hit the parameters. In the parameters, we have firstly pruning, that is on by default, and also fine-tuning. So pruning tries to remove weak cell types, and they will be set as NA. If you enable this pruning option, you will get the two aforementioned plots for sanity checking. And as said, fine-tuning tries to improve the ranking of the best label. There are also options to change the height and width of the output plots and also the label sizes of the plots. And here, there's this input files section. Make sure that you put the right object in the right slot. So for example, now this is incorrectly set. So reference object needs to be the summarized object, not the zeroed object. So I'm gonna change it. And now it's in the correct format, so we can close this. I'm gonna set these as yes, so I'm gonna leave them on by default, and I'm just gonna run the tool. Okay, the tool is finished now. So firstly, we got this zeroth object annotated. So this has now the cell type annotations, and these could be used later on. And secondly, we have the plots PDF object that has now 4 types of plots. So the first plot will show the cell types in a UMAP. Then the second and third are for sanity checking and scoring this accuracy of these labels. So here's a heat map where you can see the labels here with this color coding, and then you have the same labels here with the text, and you can see the correlation sort of that. For example, here we have this darker blue. It should be naive CD4 plus T cells, and we have the same here, and these should be yellowish because they should correlate, and so it does. And then the third plot is this delta distribution plot. You can see how many cells are pruned out. And finally, the final plot shows the cluster cell type with the maturity principle. So this last plot shows a cell type assigned for each cluster based on the maturity principle. So for example, if 70% are T cells in cluster 1, then the whole cluster, every cell in cluster 1 will be labeled as T cells in this example.